All right. Hello, everyone. Let's go ahead and get things going for today. Just wanted to start by reviewing the last couple weeks of the schedule real quick. Make sure everybody knows what's left as far as this class goes. This week, really the only thing on our agenda is the exam. So the third exam is coming up on Thursday. We're going to be spending time reviewing for it here in just a moment. You do still have some other stuff for this class, though. There's one more assignment that is due next week on Wednesday. There's one more studio that is going to be happening next week on Wednesday. And there's one more quiz as well, which is also due next week. So all of that is mostly just to try and keep things flexible, try not to dump too much stuff on you for the last couple weeks of class. I know it's a busy time. I know it's a stressful time. So this week, all you really need to worry about is the exam. That means there's no studio this week. There's no assignment due this week. There will be TAs in the labs, however, on Wednesday. So if you want to come ask exam questions, if you want to come turn in assignment 9 early, which, by the way, I would encourage you. I know assignment 9 is due after the exam, but that material is going to be on the exam. So the hope is that you will look at and, hopefully complete assignment 9 before the exam. It's good practice for the kinds of stuff that's going to be on the exam. But I am trying to give you some flexibility, so it's not officially due until next week, so that you have a little bit of extra time to work on it. But yeah, no studio in labs on Wednesday, no assignment due in labs on Wednesday. But if you want to turn in stuff, if you want to ask questions for the exam, please come. The TAs will be there. I'll be there for a bit as well. And then next week is when our last studio and last assignment's due. And then the final, you can see down here on the 2nd. But just want to, remind you all that you have an exam drop. For many students, if they do well on exams 1, 2, and 3, they choose to use that drop on the final exam, and that is perfectly okay with me. If you have an A in the class, then I don't want you to come take the final. That's just a waste of time for you and for me. You've already shown me that you know the stuff. So the grades for this exam should come back, around the 21st, 22nd or so. And also, just as a reminder, while there is no lecture next week, I will be here next week in this room from, basically 1 to normal class time, basically. It'll just be office hours, though. So if you want to come ask questions, get help on the final assignment, the exam grades might be back by then. So if you want to come talk about the exam, I will be here on Monday. But I'm not going to introduce anything. I'm not going to talk about anything. I'll just be chilling here, available to help you out with anything that you need for the last part of class. Does anybody have any questions about the schedule before we shift into exam review mode? Any questions on what's expected of you for the last few weeks? You definitely will get your exam grades back with plenty of time to help you, decide whether or not you need to or want to take the final exam. You don't have to tell me. You just show up and take it if you want to, and if you don't want to, don't show up and don't take it. It's as simple as that. I'll take it from there. Since there's no questions about the schedule, then let's switch over and talk about exam 3. Since that is the main thing on our agenda for this week. I'm going to spend a few moments just kind of covering the stuff. We've done this a couple times before, right? So we're hopefully familiar with the process at this point. But just want to point out once again that your room numbers are based on your ID. So it's the same room that you should have taken exam 1 and exam 2 in. This should be the same chart, shouldn't be any different. So please go to the same room as you took the prior exams in. Just like for the prior exams, you are allowed to bring a sheet of paper with you that has notes on it. So you can put whatever you want to on that sheet of paper. All of that is still good. And then just like the prior exams, it is only covering the material from the last 3 modules. So it's only going to cover material from modules 7, 8, and 9. Those are some pretty hefty units of material, though, right? It was a kind of a shift this last third of the class. Asked you to think about things a little bit differently. Before we hop into some review problems, let's just kind of conceptually review each of those 3 modules a little bit, starting with module 7. Module 7 is really where we shifted from, well, so, 7 is when we introduced objects. So we didn't have objects at all before Module 7. We had methods for a little while, and then before that we didn't even have methods. We just had if statements and loops. So we've been kind of really increasing the complexity of our code, the structure of our code as time goes on. Objects are defined by classes. So if I want to know how an object is going to behave, I have to take a look at the code that is in the class that defines that object. What are the two categories of things that I expect to find in a class? Can somebody tell me one of the two categories of things I would expect to find in a class? Two main categories. Yeah. Instance variables. Good. That is one of the two things that I would expect to find in a class. They're usually right up at the top. Instance variables, those define the properties, the attributes of the class. There's a relationship that has a relationship. So I could say, student has a name, student has an ID, student has a major. All of those things make sense. So that means they're a natural fit for instance variables. What's the other category of thing I'm going to find in a class? Topic I hope we're familiar with by now. Yeah. Methods, good, yeah. So methods are the behaviors. Methods are what an object can do, the actions that it can perform. So methods are typically verbs, right? They're actions, behaviors, and there's one particular kind of method that is we've spent a lot of time talking about, because a class is just a template, right? A class by itself doesn't actually do anything. In order to use that code, we have to create a specific version of that class that's called, what's that term again? Starts with an I. Specific. An instance, that's right. So I need to create a specific instance of a class to represent a specific student or a specific car or whatever object we're talking about, right? How do I create instances? Yeah. We call the constructor. So the constructor actually is a method. I think that's important to understand. Constructors are methods. They're very special kinds of methods whose purpose in life is to create instances of our objects. So that is not everything we talked about in Module 7, but kind of the high-level overview of what we talked about in Module 7, introducing those object-oriented programming basics. And then we took it a step farther with Module 8 when we introduced inheritance. So inheritance is this idea that if I have multiple objects that have some commonality between them, some similarities, I can use inheritance to take all of that common stuff and put it in one place instead of having to copy it across all of those different objects. So that one place is called the base class. And those other classes that are using that common code, using that shared code, are called the inherited classes or the derived classes. What keyword am I going to see in the code if inheritance is being used? Or maybe a better way, before I can even do inheritance, right? What do I need to type in the code to make sure that inheritance is being used? What's that keyword? It starts with an E. Yeah. Extends. Extends, that's the one. Yeah, so I say something extends something else, and as soon as I say that, all of the instance variables and the methods from that base class are now also a part of the class that is extending it. So we get all of them, and that means that any new unique functionality I can create in that inherited class, what was I going to say? So when we call the constructor, for example, one of the things that we're going to need to do, and we'll hopefully see this today when we go through some review problems, is refer back to that base class, maybe call the constructor of that base class. What's the keyword I expect to see in my code if I'm referring to something from the base class? Super, yeah, that's the one. That's the one we're looking for. And then finally, there was a mechanism that we talked about where, let's say I inherit a bunch of stuff and I look at one of the methods and I'm like, actually, I don't like that method. It doesn't work the way I need it to in this particular case. I can choose to, throw that one out and do something different. What's that called? when I inherit a method and then decide to replace one of the methods I inherit with my own version. What's that called? Remember? It's an override. That's right. It's an override. So that's what provides us a little bit of flexibility with our inheritance, because inheritance on its own does kind of a lot, right? It gives us everything. Sometimes maybe we don't want everything, so we can use an override to kind of help us pick and choose a little bit, and yeah, be a bit more specific about the kind of behavior we want. Cool. And then the last module that we talked about dealt with data structures, abstract data types. So, this is kind of a lead-in to the next class that takes place after this one, which is 247. It's called data structures. That's the name of the class. So, the two that we talked about were lists and maps. And in particular, we saw that lists are very similar to arrays, but also not exactly the same as arrays. Can somebody tell me a difference between lists and arrays? What's one thing that makes them different? Yeah.
Arrays have a set length and lists do not.
Yeah, so that's actually one of the nice things about lists. When I create an array, if I have 10 things in it, that array has 10 things in it forever, right? 10 spots forever. I can make bigger arrays and small arrays if I want to, but once I create that array, it is set in terms of how big it is. With lists, that's not true. If I add things to the list, it gets bigger. If I take things off the list, it gets smaller. So that is one very big and very important difference between arrays and lists. But there's another very big difference between the two that I think is even more relevant to the kinds of stuff we were talking about in Module 7, for example. Lists are that word that starts with an O that I've said at least 10 times already today, probably, right? Lists are objects, and arrays really aren't. So think about what that means. If I'm using a list, I have to call the constructor to create an instance of it, right? And then once I have a list, with arrays we saw that square bracket syntax, right, that we use to manipulate them. That's not how lists work. I call methods upon them, just like I do for any other object. So that's how we get stuff into the list and get stuff out of the list, is by calling methods. We're not going to be using that square bracket notation anymore. Maps, so lists and arrays, very similar in some ways, different in other ways, but very similar. Another big similarity is that they have an index. So they index that starts from 0 and counts up. Or the way that we kind of talked about that is that we say that lists and arrays, for that matter, are ordered. They keep track of the order of things. The other data structure that we talked about was pretty different. It was called a map. So instead of storing things with indices in a map, maps store things a little bit differently. Does anybody remember what maps are going to be dealing with? There's no more index, but it's now a pair. What is that pair of things that I'm going to stick into a map? Key value, yeah, key value pairs. The idea here is that instead of having a value associated with an index, like 0, 1, 2, 3, maps are kind of a create your own index situation, where I can use numbers if I want to. I could even use 0, 1, 2, 3 if I wanted to, although that would be a little silly. But I can also use any object I want. I can use strings. I can use, students. I can use any object I want to represent the key. And that means that there's no longer an order, right? Maps aren't considered ordered. The value is not associated with an index. It's associated with a key. So anytime I want to put something into a map using the put method, I have to say that this value is associated with this key. And then anytime I want to get something out of a map, I have to tell it which key I'm trying to access. But that key could be anything. It's not going to be an index, right? It could be literally anything. Cool. All right. That was kind of my, 10-minute high-level review of the 3 different modules that are going to be on this exam. I just also real quickly wanted to point out that, like the last exams, you were provided with a practice quiz as well as some coding problems. And that is kind of where I'm hoping that we will go next. We've got, a little bit over an hour's worth of time left in class today. I'm hoping that we can go through some coding problems, some practice problems. Do any of you out there have suggestions on which of the coding problems you would like to see? Anybody have any that they were working on or got stuck on or just had some questions about? I'm happy to pick some, but yeah.
Can we do
Please, yeah.
Can we do a question about polymorphism?
About polymorphism. I'm trying to think if I even have a coding problem based on polymorphism. But let's talk about, we can certainly talk about polymorphism. I don't know if I actually have a coding problem on me that uses polymorphism, to be completely honest with you. But we did talk about polymorphism a bit. Can somebody give me the textbook definition of polymorphism? Because that's just a one-liner. And then we can talk a little bit more about what it means. Because sometimes the textbook definition isn't enough to help us understand, right? All right, so let me give you the textbook definition of it, and then we can talk about what it means. Polymorphism is the idea that if there are multiple different ways that I could refer to an object in terms of its type, I'm allowed to pick whichever one I want. It comes into effect when we're dealing with inheritance. So in order to understand this concept of polymorphism, remember that inheritance has an is-a relationship. So I say that, a student is a person. That means that if I have a student object, I can refer to it as a student, but I can also refer to it as a person because a student is a person. So polymorphism says that if there are multiple types that could apply to an object, I'm allowed to use either type. And actually there could be more than two. There could even be 7, 8, 10. We didn't see any examples like that, but theoretically possible to have inheritance that goes really deep, and I could use any of those types then to refer to that particular object. It's a very useful concept, one that is only in use when inheritance is in play, though. So if we're not talking about inheritance, then don't even worry about polymorphism. I think that's actually a good thing to keep in mind for the exam. We don't need to squeeze it into other places. Yeah, great question. Sorry I don't have a coding example for you, though. That kind of tells you, should you expect a super polymorphism coding example on the exam? Maybe not so much, right? Because there's not a whole lot of practice problems that go that way. There are some inheritance practice problems, though. Any other questions? Any other suggestions before I pick a practice problem out of a hat to do one? Or not a... Yeah.
Can we do one about maps?
We do one about maps. I would love to. Be happy to. This one right here has to do with maps. So this is code writing question number 1, actually. We're asking you to make a dormitory class. So in terms of a dormitory, actually right up here at the top, you can see that I actually use, here's this magic phrase, right? Has a. Anytime you see that phrase on the exam, I want you to think, here comes the instance variables. He's about to tell me what the instance variables are going to be. So typically after I use this phrase, it'll just be a list, a bulleted list a lot of times. And if there are 4 things on that list, you better have 4 instance variables. That's usually what that means, right? So in this case, we see that a dormitory has a name, and then it has a mapping of room numbers to students. And actually, in this case, we're referring to sort of the student object that we used in assignment 7, for example, a similar type of object. In this problem, we happen to give you the instance variables. That won't always be true, though. We may have a chance to look at another example a little bit later on where we actually have to write the instance variables ourselves. But in this particular case, you were given all of the instance variables, and so the first thing that we actually have to do is write the constructor. And this is actually another thing that, if we're dealing with objects, one of the first things I'm almost always going to ask you to do is write the constructor. So the good news is the constructors follow kind of a formula. They follow kind of a straightforward approach. There are some tricky parts. There are some things that you need to think about. In terms of defining the constructor itself, it's always going to have the same name as the class that we're in. Also notice there's no return type, right? I don't type void here. So constructors don't have an explicit return type listed. That's a way that we can use to help us identify the constructor, right? By looking for that. This note says, for full credit, the constructor should only have one parameter. So think about that for a second. We have two instance variables here. The role of the constructor is to make sure that all instance variables are set to an appropriate value. And there's two ways we can do that. One way is to accept a parameter and use that to set our instance variables. The other way is if there's some known value that we wish to use. And so for in this particular case, I would ask you to pretend that you're Chancellor Martin or whatever, and you built a brand new dorm on the South 40. How many students are in that dorm after you cut the ribbon to open it? 0. No students, right? It's brand new. Nobody's moved in yet. It's all shiny. It's all new. So I'm arguing that, okay, the name is going to be my parameter, but for the actual rooms, it's going to be empty. I just want an empty map to represent the fact that this is a brand new dorm. Nobody's moved in yet. So, all right, that's going to look like this. String name. Another good tip for constructors. If you're writing a constructor, remember what the role of a constructor is. A constructor is to make sure all instance variables get set to a proper value. If I have 2 instance variables, that means I need 2 variable assignment statements in my constructor. If I have 4 instance variables, then I need 4 variable assignment statements in my constructor, right? So the first one is usually this one's pretty straightforward, although there's already an issue. What's the problem? This isn't good. It doesn't look super bad, but it actually is kind of bad. What's the issue? Yeah.
You're missing this dot.
I'm missing this. So that's the solution to the problem. Yeah, but what actually is the problem? Yeah.
It's ambiguous which name you're referring to.
Good, good. There's 2 variables called name here. There's this one, and there's this one. They are 2 separate pieces of data that just happen to have the same variable name, right? So 2 separate things. It's ambiguous. If I just say name by itself, it's ambiguous which one I'm referring to, unless, as was suggested to me, I say this dot out in front of it. So when I say this dot out in front, that is always going to be referring to an instance variable. Always. Now that being said, you don't actually have to put this dot in every time you use an instance variable, right? It's only required in situations like this, where I have 2 variables and there's ambiguity. So if that situation doesn't exist, you actually don't need it. But I am kind of in the habit of always including it, just so there's never any ambiguity, just so there's never any reason to worry about that particular situation. The other instance variable, this one's a little trickier to think about, right? In terms of how do we set this to a proper value? It should be an empty map. So one of the most common mistakes on this exam is that students won't put anything down for this at all. But you do. You have to set this to be a particular value. This is an object. So in order to use it, I need to first create an instance of it. And once I do that, I will have my empty map. So we do need to set this dot rooms to a value. What do we need to set it to? We need to call a constructor here. How do I call a constructor? What's the first word that I write down if I'm going to call a constructor? 3 letters. New, that's it. Then the name of the thing that I wish to construct, which in this case is a hash map. Because it is one of these abstract data types, we do have to put the angle brackets here. But note that I don't actually have to put anything inside of them. It's not required, right? You can put stuff inside of them. If you did, you'd put this inside of there, right? What does this represent? What do these 2 types represent? What does this first type represent? It's the type of the That's the type of the key, and this is the type of the value. So the key is going to be a room number. The value is going to be the student who's living in that room. I think for the purposes of this problem, we're assuming that only one student is going to be living in each dorm room. I know that's not accurate in real life. You could actually make it so that multiple students live in the same dorm room. That makes this problem more complicated than I want it to be. So we're going to make that simplification. But back to this. So we can leave those angle brackets empty, but we are calling a constructor. Constructor is a method, so we have to include parentheses here. I know this looks a little silly. We talked about this last week when I talked about these constructors, but all of these pieces are necessary. This is what I'm constructing. These angle brackets are required because it's an abstract data type, but they can be empty, and I would argue easiest to just leave them be empty. And then the parentheses are because we are calling a method. We're calling a constructor. So this, I think, satisfies our constructor for the dormitory. Does anybody have any questions about that before I move on to the next parts of this problem? Okay, so now we've just got the other methods. We did the constructor first. Constructor is almost always going to be first, right? And now we just have to worry about the other methods, starting with some easy ones. This method is an example of getter. Good, yeah, getters and their complement setters are usually going to be pretty straightforward. In this case, we have a getter for the name instance variable, so we're just going to return this.name. That's about as easy and straightforward as it gets. This one, even though it starts with the word get and feels kind of like a getter, it's a little bit different. We're not returning an instance variable here, at least not directly. We need to know how many rooms are occupied, which in my mind is based on how big this map is, right? So if there's 10 things in the map, then there must be 10 students living in that dorm. So I need to figure out how big this map is. I want to make sure you're all aware of the fact that on the exam, the very last sheet, the very last page of the exam is going to be a reference sheet that I provide to you that includes, it's not going to be the full documentation because that would be way too much paper, but it's going to be, you know, a condensed documentation for lists and maps to show you just kind of the basic methods that both are going to have, so that, you know, you don't need to write them down on your sheet of paper, right? In practice, we would look them up. We would go, you know, we would go into Google and we would say, you know, hash map Java, and it would pull up, you know, this page. And what I'm telling you is that I don't care about your AI overview. Right? I'm not going to be able to give you all of this. This is way too much stuff to be able to give to you, but I'm definitely going to give you the basics like the get method and the put method, right? Those are the ones that we used a lot. And there's another one down here called size that is definitely going to be on the reference as well. And that's the one that we need right here. The number of occupied rooms is equivalent to the size of the map that represents the room. So I would return rooms.size here to reflect that. All right, kind of a similar idea for this one. If I want to add a student into the dormitory, so I'm saying take this student and put them in this room. I sort of just said what the answer is supposed to be. On your reference sheet for maps, it's definitely going to have this method on it because that's how we get key value pairs into a map, is with the put method. So the solution for this part is actually very simple. It's just going to be rooms.put. And wow, Eclipse read my mind, right? Very good at guessing what I was going to decide to put in there. All right, let's move on to the next one. This one is asking whether a given room is occupied or not. So I plug in a room number like 204, and you're going to tell me true if there's a student in that room, and you're going to tell me false if there isn't a student in that room. So think about that. How are we going to make that determination? Well, I know that I have this map of room numbers to students. If I go to this map and I say, hey, tell me who's in room 204, and there's nobody in 204. What's the map going to say back to me? What does the map say if it can't find what I'm asking it for?
Null.
Null, that's right. If I go to the map and I say, tell me who's in room 204, and it has no idea what I'm talking about, it's going to say null, which is actually the map's version of saying nothing, right? There's nothing in that room. There's nothing associated with that key. Does not exist. So that's actually a tool we can use to help us, with this problem of whether it's occupied or not. If the value is null, if I ask who's in this room and the answer is null, that means it's not occupied. If I ask who's in the room and the answer is anything that's not null, right, then I know that there's somebody in there. It doesn't even matter who it is, right? I just need to know whether it's null or not. So that's one possible solution to this problem, would be to try and get the value out, and if it is not equal to null, then we know that it must be occupied. So this is one solution to this part of the problem, is to remember that, okay, things that aren't in the map are going to be null. I can check for that. I can check to see if it's null or not. There's actually another way you could do it, though, and I like to point this way out as well, because it's true for many problems. There's almost always going to be multiple ways. If, again, you go back to your reference, there's something here called contains key. I'm sorry, contains value is what I... No. Contains key is the right one. Sorry. I couldn't make up my mind there for a second. Contains key. If the key is in the map, then it tells me it's true. If the key is not in the map, it tells me it's false. So if I look up a room number, right, the room number is my key. So if the room number that I'm looking up is contained, that means there must be somebody in that room. If it's not in the map, then I would say that room's not occupied. So in other words, rooms.contains key, room number, I would argue that this also works. This is another solution to this problem. They're both okay, and I'm fine with either one. Everybody with me so far? This next one takes a bit more work. So this next one wants us, this is the return type that I've highlighted here, which hopefully doesn't make you too scared, because we've had methods that return arrays before, so why couldn't we return a list? I mean, they're very similar in that regard. So what do we want a list of? We want a list of all student ID numbers, not students, but student ID numbers of every student who is living in this particular dormitory. So, okay, let's think about how to do that. If I were using an array, and if you think back to the problems where, we solved similar problems to this with arrays, one of the first things that we did is we created a new array to hold our stuff, right? And that's actually the first thing we need to do here, except with the list. We need to create a new empty list to use to hold all the stuff. So let's go ahead and start with that. We're going to call the constructor. We're going to make a linked list of integers called student IDs, and we're going to call the constructor. And just like we saw with the map, it does require us to do this kind of funny looking angle brackets, parentheses syntax. All right, now that we have our empty list, what we need to do is go through the map and get every single student out of it, and then ask them what their ID number is, right? So in order to go through every single entry in the map, I want to remind you that we did talk briefly about how we can iterate through maps, how we can write loops to go through maps. But it's a little tricky because maps are not ordered. Maps don't have an index. So with an array and with a list, if I wanted to traverse them, I could just say for int I equals 0, I is less than the length, I plus plus. That'll work for arrays and lists, but there is no index 0 here, right? Furthermore, maps aren't ordered. So using a loop like that isn't going to work. But I'm going to look back at an example from last week, actually, when we talked about our abstract data types. I showed you two different ways that you can use to write loops to go through a map. Notice, though, that both of them are for each loops. It has to be this way, right? Because of how maps are structured, you cannot use the traditional for int I equals 0 style of loop to iterate through a map. But this is my preferred way of doing it. Think about what this is doing. This is going to grab every key out of the key set. Every key out of the key set. So actually, I'm going to grab this loop and copy it and just bring it over to the problem that I've been working on and tweak it a little bit. Actually, I don't like that idea. As soon as I pasted it in, I was like, that's not good. I'm just gonna write it from scratch. For every room number in the we need to access all of the keys. This is another one of those things that's on your reference sheet. This key set. Rooms dot key set. So now, every time we go through the loop, room number is going to take on a different key from our map. But that's not what we want. We want the values. We want the students. So in order to get the values back out, we have to plug the key in to the map and get the student back out. So that's going to be the get method, where I plug in the room number. Remember that this is going to give us back the value, which in this case is a student object. So if I wanted to, I could store that in and I do want to. Right? I could capture that in a variable like this. Plug the room number into the map, give me the student that's living there. This is another very common mistake on this problem. A lot of students would plug in the room number and assume that it's just going to give you the ID number directly. It doesn't, right? It gives you the student object. Students have an ID number. They also have a name, and they have, a GPA and all these other things, right? But we need to, once we get the student back, we need to ask the student what his ID number is. That's what we're actually after. So we could say, int ID is equal to living in dorm dot get ID. Call the getter on the student object. And then finally, we need to take this ID and stick it into this list that we created. So we would do that by saying student IDs dot add ID. And at this point, we are pretty much there. We just need to remember to return our list once we are finished. Definitely, I think the most complicated method on this problem by far. Having to remember, how to iterate through a hash set is tricky. It's definitely tricky, one of the trickier things. This part where we extract a student and then still have to ask it for the ID, also tricky. That's something a lot of students got tripped up on this particular problem. Are there any questions about this? There's still a few more parts to this problem, but any questions about this particular part? Be happy to go through it again, explain anything that's confusing. Yes?
With the... Sorry, no, I think I answered my own question.
Okay, you're good. Totally good. Happy to help out however I can. All right. So then the last part of the problem down here actually is an important one, because remember, everything that we just wrote, all of this stuff up here, this is a class, this is a template. It doesn't actually do anything, right? So this just specifies what attributes a dorm has and what behaviors a dorm has. If we actually want to create a dorm and use a dorm, right, that's a separate action. We have to actually call the constructor to make an instance. And that's what these problems are relating to down here. It says create an instance of the dormitory class. and store it in a variable called dorm. When you see that phrase, create an instance, right? Your brain should hopefully be thinking, oh, I got to call the constructor. I got to call the dormitory constructor. So, this line of code is going to look something like dormitory dorm is equal to new, because new is required every time we call the constructor dormitory. And then, what parameters do we have? Remember, I asked you to write this. So if you write a dormitory constructor that has one parameter, later on, when I tell you to call that constructor, you better give it one parameter, right? If you have two parameters, then hopefully you give it two. This one is asking for a name, the name of the dorm. A lot of students just put their own, dorm name here. I actually have never lived in a dorm on this particular campus. Trying to think of a dorm name. Fancy, shiny building that your tuition paid for. Right? Doesn't matter. I don't care what the name is. That's not important to me. What's more important to me is that you have the right number of parameters and can call that constructor appropriately. The next one asks you to create an instance of student, which I actually think is maybe a little bit mean in this particular case, because I did provide you a student class here, but it's pretty bare bones. You can see that it's just got an ID number, basically. It doesn't have any of the extra stuff. I think in practice, if I were to go back and do this over again, I would probably be like, given a variable containing a student, right? Add that student to the dorm. But if we're trying to compute this problem as written, I'll create a student S and give it a, I think the only thing I have to give it is an ID number. And now that I have this student S, I can add it to the dorm. It said we can choose whatever room we want to add it to, so that's good. So the method that we have up here is add student. This is another part where people would get tripped up. One thing that I saw students try to do on this question is this: rooms.put 204S. Why is this not an acceptable answer here? Why can't I do it this way? I see answers like this a lot when I ask these kinds of questions. Why is this not what I'm looking for? What is rooms? If you had to label it.
The map.
It's a map. It's an instance variable. Rooms is an instance variable of a dormitory. The only way that I can access an instance variable of a dormitory is through the dormitory instance, right? I can't just access it directly. I have to go through an instance. The way that we do that is by calling the methods that are contained in the dormitory class. Specifically, we have one for adding a student. It's called add student, right? And yeah, it calls rooms.put, but okay. I mean, that's just, like I said, that's just the template. That's just how the implementation instructions, right? If we're thinking about it from the object-oriented programming perspective, I call methods upon instances, not instance variables, but instances. So here, I would need to say dorm.addStudent, and then plug in, a room number. I keep using 204 because that's my office number, and the student that I want to add. So this is the correct way to add a student to the dorm. You cannot just say rooms, because what dorm is rooms associated with, right? Every dorm is going to have its own map called rooms. So if you just say rooms, I have no idea which dorm you're talking about. You need to tell me the specific dorm instance that you're trying to add this student to. And then last, but certainly not least, this problem down here, also a bit tricky, wants us to write code to determine if the student with this ID number is in the dorm using the appropriate methods. So we need to get the list of all student IDs. And again, I would encourage you, okay, maybe on the exam you think you botched this part, right? You didn't get this part exactly right. That's okay. You can still answer this question, right? Call the method that's supposed to get the list of student IDs and just assume that it's going to work properly. They're two different problems, so you won't be double counted or anything like that. The first thing we need to do is we need to get this list of student IDs. So I would say dorm.get student IDs. But I probably want to save that in a variable. Probably want to store that in a variable. So, okay, linked list of integers student IDs. Now I have this list. On your reference sheet, you'll also see, not just stuff for hash maps, but also for lists. And one of the items that you'll see on your reference sheet for lists is going to be a convenient little method. Wow, my computer's going really slow today. What's that about? Convenient little method called contains. It tells me if a list contains a particular value or not. So to wrap this problem up, I would say student IDs.contains 1, 2, 3, 4, 5, 6. There was a lot of ground we covered on this problem. But I think this is a pretty accurate example of the kinds of problems you might expect to see on the exam. Does anybody have any questions about what we've covered? Anybody have any questions? Happy to go over any of these parts again if you are confused or stuck. Does anybody have another practice problem they'd like to see me go through? Or do you just want me to pick one? Anybody have any examples they were hoping to see today? Okay. If not, I'm going to go through, I think, an inheritance one, because I think that's an important concept to cover. Code writing number 5 down here is an inheritance problem. So I'm going to switch and look at that one. Actually, this first part of it, the computer class, that's the base class. So there's no inheritance happening here, right? This is going to be inherited later, but we're not actually using any inheritance yet. So this is really just another object-oriented programming problem, kind of like the last one that we did. In fact, I would argue it's even simpler than the last one we did. There's no lists involved. There's no maps involved. So pretty straightforward object. Let's read through and work through it real quick and then talk about inheritance. We're going to create a computer class, and specifically we're interested in keeping track of the state of the computer. So whether it's on, whether it's off, or whether it's in sleep mode, right? Because your computer can go to sleep, which is not really on, not really off, but kind of somewhere in between. So we gave you the instance variables for this problem. Another example where we gave you the instance variables. You can see there's just two Booleans, one that tells me whether it's on or off, and one that tells me whether it's asleep or not. And our first task, surprise, surprise, hopefully shouldn't be a surprise, is to write the constructor for this. And it tells us when a computer is created, it should be completely off. So, okay, let me go ahead and set up my constructor. The main question, one of the main questions for the constructor is, what parameters do I need? And in this case, I'm going to make the argument that I don't need any. It says right here, when a computer is created, it should be completely off. So in my mind, I interpret that as these should both be false. So I can just say that. I can just say is on is equal to false, and is asleep is equal to false. I can just say that. Right? I also think this is accurate. If you think about constructing a computer, right? Comes off the assembly line or whatever, it's off. I put the finishing touches, it's off. Somebody may eventually turn it on and test it, but a brand new computer out of the box is going to be off, all the way off. Okay, now that we've got the constructor done, there's, I think, only one method down here for us to do for this class, which is called push power button. So if the computer is on and you push the power button, it depends on how long you push the power button, right? If I just tap it, that doesn't turn my computer off, that just puts it to sleep. But if I want to turn my computer off, I have to push the power button down and I have to hold it down, right, for a few seconds. So this has a parameter called long press. If this is true, that means I held the power button down for a long time. If this is false, that means that I just tapped it. I didn't push it down for a long time, I just tapped it. So the behavior is going to depend on, did I push the button down for a long time or not? But it's also going to depend on, is this computer on or not, right? Because the instructions, the way that they're written, it says if the button press is short, the computer should go to sleep but remain on, or if it is asleep, it should wake up. If the button press is short and the computer is off, it actually doesn't say anything, and I think we can just ignore that situation. It doesn't say what to do, right? So we don't need to worry about it. So let's go ahead and start typing this up. If long press is false, that means a short press. We also want to check to see if the computer is on. And you can say equals true here. That's a little bit redundant, but doesn't hurt anything. All right, so if I just do a tiny press and the computer is on, so think about what we need to do next. If it's asleep, I want to wake it up. And if it's not asleep, I want to put it to sleep. I think there's a simple way to do this. You could, do this more directly if you wanted to, but we're really just flipping it, right? If is asleep is false, I want it to become true, and if it is true, I want it to become false. So we really just want to flip it. I think we can do that very simply just by saying is asleep is equal to not is asleep. So if it's true now, it'll be false, meaning I've woken the computer up. And if it's false now, it'll be true, meaning I've put the computer to sleep. There are other ways you could write this out if it makes you feel more comfortable to have an if-else statement or something along those lines. I'm not going to complain. Let's talk about the other situation, though. If the button press is long, the computer should either turn off or turn on, depending on its current state. So that's going to be down here. Long press is down here. I don't think we need to ask whether it's asleep or not, right? If the computer is, if I push the button for a long time, that computer is either turning off or it's turning on. The opposite of whatever it is. Now, it's a similar story. I would say something like is on is equal to not is on in this particular case. This is my solution to this method. I think it works pretty well. I've seen plenty of other solutions to this though, and other solutions that work too. This definitely isn't the only one, but this is kind of how I envision this problem. Does anybody have any questions about my approach here before we move over to the inheritance side of things? Yes?
In the constructor for this,
Yes?
why are both instance variables false?
Yeah, I think so. You raise an important question. This statement says it should be completely off. I think that is enough to make this determination, right? This one is a little ambiguous. Whether, should asleep be false or should it be true? I mean, if the computer's off, does this one even really do anything? Does it matter at all? I think this question was on an exam like a year ago or maybe a year and a half ago. I think I was pretty loosey-goosey about how I graded this particular instance variable because it's ambiguous enough, right? I'll always try to give you the benefit of the doubt. This one was not ambiguous at all, though. It very clearly said it should be off, so that one had to be marked false. This one I happily took either way. I don't remember if I accepted parameters here or not. I mean, if I had to ask this problem again, I would be more clear and less ambiguous. I'm not trying to be ambiguous on the exams. I'm trying to be very explicit. So hopefully you don't run into any situations like that. Just know that if it happens, which it does happen, I'm human, I make mistakes, I'll try to give you the benefit of the doubt and grade it as liberally, leniently as I possibly can. I always do. I always try to. Yeah. A little ambiguity there, though. I agree. Any other questions about this before we switch over to the inheritance side of things? Yeah.
No,
you're fine. You're fine.
Question about the constructor. Why did you choose to just have the instance variables just as them instead of like this dot the instance variables?
Yeah. Why did I do that? So I said earlier I've kind of trained myself to put this dot out in front. I've also said that it's not required, so it's only required if there's ambiguity. In this case, there is no ambiguity. So if you want to know why I didn't include it this time, it's because I was trying to go faster. That's literally it, right? I was just trying to take a shortcut and not type as much stuff so we can get as much review questions in as possible. Like, if I am being careful and thorough, usually I will put it on front. If I'm trying to be fast and take shortcuts, then I'll leave it off. And like can sometimes happen when you're fast and take shortcuts, sometimes that causes problems, right? Sometimes when you take shortcuts and you're not super thorough, that can lead you to some ambiguous situations. So you do have to be careful. Yeah, good question. All right, let's switch over to the second part of this problem, which is the laptop class. So right here it says a laptop is a computer. That is the relationship, right, that we discussed as being the one that inheritance defines, is a. So when you see this phrase, I want those alarm bells to be going off. Say, oh, inheritance is happening here, and specifically, this class is inheriting from this class. That is what this statement means. If I say something is a something, the right-hand side is the base class, and the left-hand side is the one that's doing the inheriting from the base class. How do I say that in my code? What do I need to do to reflect this statement in my code? Talked about this a little bit earlier. Extends, yeah, there it is. So up here we got to say extends computer. When we say that, that inherits all of the instance variables, that inherits all of the methods from the computer class to the laptop class. But laptops are different from computers in some ways. So, when I say computer, I'm thinking about like my PC at home. It's more of a gaming setup, right? Where it doesn't move. It just sits on my desk. I can't, take it anywhere. It's a desktop PC, whereas laptops are portable, but also they open and close. So, laptops have the ability to open and close, and that has an effect on the state, right? If I were to close my laptop right now, it wouldn't turn off, but it would go to sleep, right? And if I opened it back up again, it would wake up. That's how laptops are usually designed to work. So we need to include an instance variable to track whether the laptop is currently open or not. And just like we saw with the other instance variables just like we saw with the other instance variables we've been working with, I think that's a Boolean. The laptop's either open or it's not. So, okay. Here, finally, we have one that says, put your instance variable here. What's the first thing I'm going to type? Private. Yes, private, private, private. Must mark them private. I will be looking for that. Absolutely. Private Boolean is open. How many instance variables does this laptop class have total now? It's not one. It's three, right? The one that I have here plus the two that I'm inheriting from the computer class. It has three. So definitely keep that in mind. Next up, we're going to write the constructor. It says when a laptop is first created, it should be closed. Okay, so you told me it should be closed. That means that I'm going to set this to be false. But that's not the only thing that I have to do in my constructor, right? Whenever we're using inheritance, the first step of the constructor is to call the constructor of the base class. That's always going to be the first step. So before I worry about, setting this instance variable, I'm going to take care of calling the constructor for the base class, and I do that by typing super. Here comes that super keyword. I'm calling the constructor, which is a method, so I need the parentheses. And furthermore, right, I need to make sure I'm calling it properly. So if I go back to the computer class here, I see that this constructor has 0 parameters. Okay, that's good. That means I don't have to put anything inside the parentheses here. But if it did have parameters, then I would need to specify what they are. And that might mean that I need to have, parameters come in here that get passed to the constructor of the base class. We've seen examples like that a couple weeks ago when we did inheritance in class, also on the assignment. In this case, it's simple. No parameters to any constructors, so pretty straightforward call to super. And now that takes care of 2 of the instance variables, the 2 that we inherited. We just have to take care of this one, which we said we know it's going to be closed, so we'll just say this dot is open is equal to false. All laptops start closed. And they also start off as well because of the way the constructor is set up for the base class, right? They all start off. All right, we've got a couple of different methods here. Notice that these methods wouldn't have made sense in the base class. I can't, again, if I think about my desktop PC at home, I can't open it. I can't close it. Not like a laptop anyway. I guess I can open the case or whatever, but it's not something I do all the time. So we have to think about, okay, I need to track the state of the laptop, but then also opening and closing it affects the sleep mode. So if the laptop is on and I close it, that puts it to sleep. And if the laptop is on and I open it, that wakes it up. So, okay, let's take a look at these methods. I think the first thing, and one that is, I think, somewhat obvious, but also kind of easy to miss. If I'm closing the laptop, then I need to make sure, before I do anything else, that is open is set to be false, right? Close the laptop. And the same thing's true for open. If I'm opening the laptop, then is open needs to be set to be true. It's an easy one to overlook, but we're trying to keep things accurate. We're trying to track the state accurately. For this next part, it says if it is on. Okay, so if it's off, I don't need to worry about anything. Only if it's on. Well, let's check that. If this dot is on, and uh-oh, we now have a problem. What's the problem? Is on is definitely an instance variable, right? Why can't I access it? Why can't I do it? Why can't I do it this way? Where's this one coming from? It's not in this class, right? We inherited it. We inherited it from the computer class, and it's marked private. So I can't access it because of that reason. It doesn't matter that we're using inheritance. If it's marked private, I cannot access that instance variable outside of the class where it's been declared. I'm not allowed to do that. What's the solution? A getter. Getters and setters. And actually, I skipped over this before. Maybe I should have mentioned it. But, oh, hey, there's a whole bunch of getters and setters provided for you. These were just given to you to use, including, one for the is on variable. So, okay, cool. Let's switch back over. I know this seems a little bit silly. This code doesn't work because I'm trying to access the instance variable. To call the getter, really all I need to do is put the parentheses on there to indicate that I'm calling the get method, right? Instead of trying to access the instance variable directly. This will work. Calling the getter works. And now I just need to put it to sleep. So if I close the laptop, I need to put it to sleep. But actually, we kind of have the same problem, right? This dot is asleep equals true. I can't do this for the same reasons, right? It is marked private. So I have to use, in this case, not a getter, but the setter that you were provided. So, okay, instead of like this, we're going to say this dot set asleep true. And that is definitely tricky. Remembering that, okay, I can't access instance variables directly, have to use getters and setters. That is definitely tricky. We're going to have a similar if statement down here for opening the laptop. Except instead of saying set asleep true, we'll say set asleep false, because we're waking it up again. I think that does it for close and open. They're very similar, but opposite, right, as you can see. Does anybody have any questions about these two methods before I scroll down and take a look at the what I believe to be the last method? Okay, then let's take a look at this one. Oh, hey, we've actually seen this method before, right? This method exists in the computer class right here. We wrote it earlier, which means that when I did this, I actually should have inherited that method. So why then am I asking you to do it again? Or maybe a better question is, what am I asking you to do here? I'm asking you to override this method. I'm saying that the method from the base class actually doesn't quite do what I need it to do. So, and to understand why, think if the laptop is closed, I'm saying that we should just ignore anything, right? My power button is right here. If my laptop is closed, I can't push it. It's physically inaccessible to me, right? Cannot access the power button. So I'm trying to say, hey, if the laptop is closed, then don't do anything. You can't push the power button. It's not accessible to you. If the laptop is open, then I just want you to run the power button the same way you would normally. So let's put that into code here. If the laptop is open, so if this dot is open, well, in this case, I just want to, I want the power button to work normally. I want it to work the way that it would for any other computer. In other words, I want to reuse the push power button method from my base class. That's what it says here. It says, should simply call the push power button method from the base class. How do I do that? Super again. That's right. Super. This time, so if you see super followed by parentheses, that's a constructor, right? This time we need a dot. Super dot. I'm not calling the constructor. I'm calling a different method. So I'll say super dot push power button. I'm just going to take the parameter that was given to me for this version of the method and pass it right along and let it do its thing. So now I'm reusing this code from the base class and just adding a little tweak for the laptop to check whether it's open or not. This is a great use of inheritance, right? I don't have to recopy all the code that was from here. I can just call that method directly using super. That's inheritance in action. Yeah, that's it. I believe that's it for this particular problem. But does anybody have any questions about this one? Any questions at all? All right. We have about 10 minutes left. I don't know if I'm going to get through all of this one that I want to show you. But I do at least want to get started on, oh, here we go. Let's do this bike one, code reading question number 2. I probably won't have time to get through this whole problem, but I do want to walk through at least part of this, part of these kinds of problems, because this is an example of a kind of problem you could see on the exam. These code reading problems that deal with objects. Up here at the top, you can see I've declared a class called bike. Here's my instance variables. Here's my constructor. Here are the methods for shifting up and shifting down and pedaling the bike. All of that's good, but what I'm more interested in is what's going on down here. So hopefully you see stuff like this. It's saying, what will print? Well, if you come across a problem that looks like this and it's dealing with classes specifically, this should be your cue to make one of those diagrams that I've made in class a few times now that keeps track of the different objects. So to solve this problem properly, I really want to sketch out something. I'm going to do it on my laptop, but I would honestly prefer a sheet of paper if I were doing it just by myself. Sketch out, a diagram showing all of the different objects throughout the course of the problem. Remember that when you see a line like this, especially if it contains the word new, that's important. That means that I'm creating a new instance. So anytime you see that new keyword, that means I'm going to add a new circle to my diagram to represent that object that's being created. And the instance variable, I usually put inside of there. So I'm telling you what the max gear is, and current gear always starts at 1. So in this case, if I wanted to draw this diagram, I would make a circle to represent my new bike, where the max gear is 10, and it should be 10, and the current gear is 1. But on the left-hand side, I'm actually creating a variable that points at that instance. So this is kind of what we talked about when I went through similar examples last week. So I drew the circle in response to this that contains the instance variables. But in response to this over here, I'm going to draw an arrow. And label it 10 speed, right? And similar thing for this one. This line would tell me to do a similar thing, right? It would say to make a new bike that's going to be an 18 speed instead. So I would draw my circle and I would put in the max gears is 18, but the current gear always starts at 1, so I'm going to start out at 1. And here I'm going to draw my arrow to represent the fact that I'm creating a variable called 18 speed that points at it. And then after you do those two lines, you can see that it calls some methods and so on and so forth. But what I'm interested in getting to is down here. On line 40, it says bike Huffy is equal to 18 speed. Notice that there's no new keyword here. I'm not calling the constructor. I am not going to add a new circle to my diagram, but I am still going to do this part, which says make another arrow called Huffy that is pointing at the same circle that this one is pointing at. So if I'm going to update my diagram, that means that I would have this pointing here, like this, and it would say Huffy. Whoops, what happened? Where did it go? Huffy. Now think about what that means. That means that if I pedal the Huffy, and that changes the instance variables, right? If I pedal it, that also changes 18 speed because they're both pointing at the same bike. 18 speed and Huffy are the same bike. So if I make a change to one of them, I'm actually going to see that change reflected in the other one because they're the same thing. They're the same thing. This is the Professor Shook Dad scenario that I talked about last week, right? Where I can have two different labels that refer to the same instance, the same object. And actually this problem goes really crazy right here where it says 10 speed is equal to Huffy. Now wait a second. 10 speed is over here, and now you're saying it's equal to Huffy. What is that telling you to do? That's telling you actually that this arrow is no longer going to point at this circle at all, but it's going to be effectively, erased, right? And I'm going to move it over here. So now 10 speed is pointing at the same instance as 18 speed and Huffy. By the end of this problem, right, all three bike variables that I have are pointing at the same bike, which means that if I change any one of those three, I will see those changes reflected across all of them because they are the same bike. Think about it this way. If I shift, the Huffy up 5 gears, and then I look at the 10 speed, it's going to see that it was shifted up 5 gears, right? Because they're looking at the same bike. So this is, I think, one of the more complicated types of code reading problems. And that's why I wanted to make sure to bring this to your attention. The big thing to keep in mind is when you see that new keyword followed by the constructor, that's when I'm creating a new instance. If you just see a variable declared like this, then I'm not creating a new thing. I'm just telling the arrow to point at an already existing thing. And so then, when I shift the 18 speed down 7, it also shifts the Huffy down 7, and it also shifts the 10 speed down 7 because they are all referring to the same bike. It's a complicated concept. I know I've said it a few times. Hopefully it's starting to kind of sink in, starting to kind of gel a little bit. But the really big takeaway for this problem, and I think leaky cup is another example of this style of problem down here. You need to draw the diagram. Please draw the diagram, update the instance variables as they change. I didn't do that for this problem because I'm running out of time. But in practice, I would update the instance variables inside the circle every time they change, right? So that I can see exactly where everything stands at every moment in time throughout the entire problem. Any questions about that? Or yes?
I just wanted to ask about the equality syntax again, just the one referring to the same instance.
Yeah.
versus the same.
Yeah, so there's two ways to do equality. There's dot equals and there's double equals. So dot equals says check the instance variables and see if they are the same. So if I have two objects and I say dot equals, I'm looking to see if the instance variables are the same. And if they are, then dot equals says true. And if the instance variables are different, it says false. So dot equals can return true if I have two different objects that look identical. It's the identical twin, basically. I'm looking for a copy. Double equals is only true if they're actually the same thing. So double equals has nothing to do with the instance variables. Double equals is asking, do both of these arrows point at the same circle? So if I say 10 speed double equals 18 speed, that would be true because they're both pointing at this same bike. If I had two separate bikes that look exactly the same, right? Same number of gears, same everything, but they're two separate bikes, double equals would still be false. Because even though they look the same, they have the same instance variables, same values for the instance variables, they're two separate bikes that just happen to be identical to each other. So double equals would be false, but dot equals in that situation would still be true. Another way to think about this, if dot equals is true, I have two objects. Or actually, could also just be one object, the same object on the left and right. But if double equals is true, I know there's only one object. I know that the thing on the left is the same as the object on the right. There is no doppelganger. There is no identical twin. Double equals means they are the same thing. They are the exact same instance. Yeah, great question. I think we're about out of time, though. So I'm going to go ahead and wrap it up here. If you have any other questions, I'd be happy to stay and chat for a few minutes. I recorded the review session from the first class, and we did go through some slightly different problems. So if you want to take a look at that video for some extra review, that might be okay. Otherwise, yeah, come to the labs. If you have questions or want to turn in assignments, I'll either see you there on Wednesday or at the exam on Thursday. Have a great week, everyone.